Thank you. Okay, so yeah, today I will be speaking about achieving end-to-end type safety. And we'll get later to the details. Who am I? I'm from Novi Sad, as Ellen already said, and I worked with Node, JavaScript, TypeScript. I'm coming from EPAM. We have a booth in front. You should come. There are some cool stickers and some cool games. You can play basketball, but it can be harder to throw the ball in the rim. And I'm also AWS community builder. Oop. Okay, it's now. So who I'm not? If you are from Balkan, if you try to Google Dragan Jovanovic, this guy will show up. And I don't know to sing, but today at the party after 2 p.m., after 2 a.m., and if you go somewhere else, yeah, I might sing it. So don't be surprised on that. So this is the story of one of the best dev experience I had in a long run. Over the years, like worked with both JavaScript, TypeScript, with REST APIs, and with like other APIs, and it kind of worked, but there are better ways. So hero of this story is going to be a tRPC. And why then pool is on side, it's just because I like that hero, and I wanted to show some hero in this image. But yeah, we'll speak more about tRPC on this talk, and how we use that one to build our APIs who are going to be type safe. So why end-to-end type safety? As I said, there is better dev experience, and it matters a lot, because if you're working in a startup and you want to build something, you also want to get people who want to work on that stack. And dev experience kind of gets neglected a lot. Like you work with something, but a lot of things got thrown to the front end. And like, yeah, you can patch that. It's easier to fetch the errors between your input and output when they break with API contracts. And this sounds like a sales pitch, this sentence, but it's not. The whole idea is that if something you change on the backend under your API, it should actually reflect directly on the front end. You shouldn't experience that you have to redefine everything on the front end, all of the types, all of the inputs and arguments. So you can think about our backend that is going to get certain inputs and is going to give us certain outputs, certain type that we actually want to get. And these inputs on the GET request, they are usually query params. On the POST request is body. And there is a distinction, in my opinion, between application API and data API. So when we work on our front-end application, if you have a backend and you build it in REST API, people usually push back on some changes and say, yeah, they treat you like a client. And yet you have to do some gymnastics on the front end in order to get all of the data. But data API is more used for, and like some third-party clients who want to integrate with your application. But your application should be able to fetch some things through application API. And that was also the idea of GraphQL. So I said that this is a story how we transitioned from one to another thing. And let's see what we had previously and what was the problem with it. So I know that this looks familiar, and somebody can scream already monorepo, but yeah, wait for it. So how it worked is that if we clone the repository with certain shared types, we update that in our repository and we push that. And we also update the version of that one. And you can see it like this. So basically, update certain types that are shared, push them to the repository, and then push that to GitHub packages. And it created a lot of problems because if you're working like that and somebody merged before you, yeah, you have to raise them. Who's going to merge? Who's going to work with it? And the problem is that you cannot share actually everything that easily. if you have some repository, or even if it's monorepo, like it's hard to share all of the things that you are sending from front end to the backend. And yeah, as we finish publishing the package, we usually install that on our front end and our backend. And then we work with them. Like we define, I'm going to send the user, which is going to be of user type. But backend changes, and then things break. So this is something familiar that you usually see. If you worked with, at some point with even Angular, but in React, like you usually define certain types on the front end, and we say, okay, here is a create tag, and it's going to accept, like it has like values like string, and has certain other properties. Once we do that, we usually define some functions, and in these functions we say, hey, go to the API, fetch something, but we also define the arguments. So for example, this function says, yeah, we have the data, and it's going to be of type create tags. And it's going to return the promise tag. And the problem with this one is that this response.data, it's not type safe at all. And you would usually get something from that one, but if you change something on the backend, you have to fix that on the front end. If you are sending different arguments to backend, you have to change again. And then we would go to our component and import this service and these types. And then we would define certain function where we basically says, call this service create. Even if you're using the React query, like you would get certain states like loading, errors, and everything, but still these functions that you created to communicate with API, they are not actually type safe, and you have to change them. And somebody can say, yeah, just export more types from the backend. That would mean like I have to name all of these types, and I'm bad at naming. Because I can name it create user tag request, and then something else come up, and I have to come up with a longer name. And if I have to import something, it's again hard to know what do I want to import. And we have a villain in this story, of course, because it's a story. And as every villain, this one also has a red eye. For some reason, all villains have the red eye. So what are the villains in this story? So it's loose coupling. Our front end is actually loosely coupled to the backend. There are differences like that they can change on their own. Of course, multi-repository structure is also a villain. And our errors. Because what I mean by errors, like your backend, even in these shared types, it can extend certain things and add new properties to it. So you would need, again, to do that on the front end, because you don't want to send two HTTP requests to fetch something. You want to have application API on your front end. So what would Gordon Ramsay say on this one? It's not good enough. He has also some worse words, but I'm not going to use that one. So what we actually picked is the idea of tRPC plus React Query. And React Query, we wanted to use that because we already were on React Query, and we didn't want to transition from that. And I'm assuming at this point, like, who's using React Query on their project? Yeah, not most of the people. Interesting. But yeah, you basically get everything from your API. You get all of the states that you don't have to redefine. Like I worked with Redux at some point, and it was painful. It was really painful to do some basic things to hold this state and share it. So that was the reason why we used React Query plus tRPC. And tRPC has a pretty good integration with React Query. So we didn't have to do any gymnastics on the front end again to just connect them. So to continue what we picked, it's the RPC procedures. We'll get to that one. We got easy integration. We got integration with Zod, integration with React Query, and fast development. And we'll get to each one of them as we go through presentation. But last one, fast development, I think can be like that I'm lying about that. But I actually experienced that, and that was why it was probably the best dev experience. Because we were able to move fast and ship the value, instead of focusing on things that we didn't care. And there was some communication that we want to do and build the REST API, and it has a bunch of abstraction around that. But it was done for the startup. And if we'd done that, we would actually be much, much slower to deliver things when it's critical to deliver them. Okay, so far I'm probably sounding like this. I'm trying to sell you some shiny new application, and it has everything hidden behind. So we'll see how it goes. I know this because I can see people giving me this stare. I'm not sure what it means, but I'm assuming that it's just about the tRPC. So let's speak about tRPC. By the way, does anybody here use tRPC on the project? Okay, yeah, one hand, because we work together. Okay, maybe I try to convince you that it's worth it. So let's make a first distinction. It's mutation and queries. And you heard this about the GraphQL. It also has the mutation and queries. And does anybody use GraphQL on the project? Okay, a little bit more hands. Cool. So we can think about the queries as something to get in the data and mutation to modify the data. So if we would speak about your REST API, basically get request is a query. And anything about the mutation, it's post, put, patch. So what is the RPC? The basic idea on the right, you can see that we have a backend application, and it has certain tRPC server created, and it has tags router. And this tags router has get and create. So we basically define what this router is going to contain. And once we do that, we can actually connect that on our frontend. And our frontend now can actually know, hey, I have tRPC client, and it has tags router, get and create. And this is based on JSON RPC idea that was created a few years ago. And then once we do that, our React application basically use this client, and then we can call that directly from our components. So you no longer have to redefine anything on your side. You no longer have to think about, yeah, it's going to be API slash v1 slash something slash that. So it's insane. I think it's okay, but you might not need that for your frontend. So let's look how this looks in code. So I said that it's easy integration. We worked with Firebase functions. So it was basically Google Cloud, where we execute things in the cloud through the lambdas. And the whole idea was that we don't have like one entry point, but we switched basically to Express because tRPC has a pretty nice integration with Express, and it has also integration with different frameworks. So for example, you can hook that into Next.js easily. And the idea was that we didn't want to rewrite our code base just to do some basic things and get the type safety. I'm trying to find a word. Okay, so you can see here, we just defined the tags router, and that's it. We said that it has tags object and it's tags router. And we export this application router, actually. And it's important because this application router actually gets imported on the front end. So you have this application router on the front end as a type. And that's enough for you to, in your component, know, okay, I'm going to call that. So what's happening with the router? Router, as I said, it has procedures, and it has a query and mutation. And this one is procedure with query. So we are going to get certain data. In this situation, you can see it's returning the promise with array of tags. And same thing is mutations. And this one is, again, about adding something into the database and modifying the data. And it's going to return the promise tag. And I said that it has a good integration with Zod. So we leverage Zod on multiple things. We kind of leverage that because we use Firebase, And Firebase is not allowing you to have type safety when you push to database. Like it's not like you were using the Prisma or Drizzle or RM or something like that. But we use Firebase, so we use the ZOD to validate things before we push them to database. And ZOD is actually that. So you give it some object and says, hey, is it okay? If it's not, throw error. And that's what actually tRPC is using on the inputs. So here on the inputs, you would actually pass the ZOD object and say, this is my input to my procedure. So you don't have to care about anything else. It will validate it on its own and return to you errors if they exist. And here is the part about the express. So tRPC has this create express middleware, and we kind of just connected that directly to the router. So every request that would go to /tRPC would actually go to our tRPC router. And that was it. Like, we didn't have to do anything else on that side. And the funny thing is that guy who integrated all of this, he has done that in like 1 to 2 days. And then we started switching to tRPC. So we didn't lose like half a year just to build the API that's type safe. Like we've done that pretty quickly. And this was because of these adapters. So we didn't have to change much on our backend. But again, how does this achieve the end-to-end type safety? So let's go. So on our frontend, hopefully you can see this. On our frontend, as I said, we import the application router. And this application router is coming from the backend. And then we import create tRPC React. And once we import that, we can actually create the client that's going to work with React. And you can see on this one that we are passing the application router to it. And that's all that you have to do to have tRPC on the front end. You would actually connect it like that. Plus one more thing. But yeah, we'll get to that. And there is option to have the tRPC client, and this one is the barebone client. We actually, I don't think ever used it, maybe in a year once, because everything was done mostly through React query and tRPC in the integration. But like barebone client would be something that you want to trigger at some point that maybe doesn't live in React at some point, and you don't want to use it like that. But here is also the fun part that I actually like. So I was saying that we have option to know our inputs and our outputs. And at the bottom, you can see that we are inferring router outputs. And this one is going to infer everything that our procedures are returning. So you can actually, if I have tags get, I can actually connect this on my front end and say, hey, give me the type that this procedure is going to return. And same is with inputs. Inputs are everything that you define with the ZOD. And the whole idea is that you can now actually use them for the props on your components. So you no longer have to redefine types, actually, and you don't have to share them. Basically, tRPC is the source of truth here, and it's going to allow you to get all of these types. Yeah. But you, not actually the tRPC server. You connect that directly to the Express. Or if you are using the Next, you'll see later, you can create Next middleware. So you will have only one route that's actually tRPC in the Next. And there are multiple adapters. I don't know all of them, of course. I used only those that I need. But there are multiple adapters that you can actually hook to them. And I kind of liked it that it worked with Express because it's kind of widely spread. Even if there can be replacements for it, it was easier for us to wrap into the Express because it was easier to deploy to the GCP like that. And we had Lambda functions, we just wrap them and push to the repository. And as I said, you can use them as a types in your components. Maybe you don't want to use them like this. You can create certain types that you actually export from router inputs. But you can see that now create tag is no longer coming from the front end. it's actually coming from the backend. And this create tag, the whole idea is that you can use it through your code. And it's going to be connected. Like if backend changes, it's going also to change. And here is how you would use the tRPC. The whole idea is that you have tRPC tags.create and use query. Actually here, use mutation. And you get a function mutate, which is actually type safe and connected to the backend. So if backend changes, everything is going to change here also. It's going to say, hey, you are passing parameters that no longer exist. And that's kind of powerful to me. And that's why I actually fell in love with it. And you can connect that to the forms. And you can see, like above a little bit, when we use form, we actually use our create tag. So it's that same type, nothing is changing. So what we got after everything? So services are removed entirely. You don't have to redefine anything on your front end to use whatever library is now good for the fetch, for fetching the data. Is it fetch? Is it old Axios or anything? You don't have to do anything like that. But yeah, you have to use probably React. There are some good integrations with Vue too, but I don't think that it has good integration with Angular. I think it's a little bit different ecosystem. But yeah, it has pretty good integration with React. And we actually got tight coupled types. And that's what I was saying, like backend changes, frontend changes. Nothing is actually hidden. And what about the queries? So for the queries, it's the same story. You can do trpc.tags.get.useQuery. And you get actually data that's type safe. And you have tags and this array of tags. And you can see that we also have router inputs, router outputs, sorry. So router outputs is what our tags get is going to return to us. And the whole idea that you now have a tag which is actually connected to what you are sending from the backend. You didn't have to redefine anything again. And then you can use that on the props. I guess you can define certain like these types in somewhere in your project that are based on router outputs, and you can just export them. You can hide that you are using the router outputs. So in the end, what we got, and we got actually that backend types are source of truth for everything. We no longer have the idea that source of truth doesn't exist. Actually, backend was the source of truth when you define the types. It can be tricky if you don't work with projects where you are actually a full stack engineer. If everything is disconnected and you have front and back end engineers and they are working, somebody is working in Java, somebody is working in React, yeah, it's not, you cannot use tRPC. So you have to have the full stack engineers to work on that one. And what's funny is that tRPC actually, like if you go to their site, they're going to say move fast and break nothing. And it's kind of a good promise in the end. And as I said, it's ideal if you're using that with monorepo. You can use it without monorepo, but it's coming like, again, with some problems where you have to publish packages, you have to install them, and I don't think anybody wants to do that, because if there is a friction to deliver something and work with something, yeah, nobody is going to use that. So we also have the permissions, and they're coming in a way that you already know. So you, on every backend, you usually saw that there are middlewares, and these middlewares are also in the tRPC because Express is also the middleware. But you can do it like on like every framework. So here we would actually define certain tRPC middleware, and this middleware like was called check user role. If something is broken, throw tRPC error, and tRPC is going to return that as a JSON in the end. And anybody can consume that. If everything is okay, pass to the next one. And then you can attach them to procedures. And you can have multiple middlewares as in every framework. what is also interesting that you can define these procedures in different files. So for example, I can define admin procedures, and it's going to be like procedure.use and this function that actually check user role. And then you can use here admin procedure. So you don't have to do anything like to define these use all over the place. So demo time, because everything breaks on the demo. And let's see how it goes. Hopefully better. Okay, so do you see everything? Okay, cool. So what we have here is that this API, it's actually tRPC React next, because I'm using the next here. And what's happening, if I hover over these tags, you can see that it has ID and name string, and it has certain values. And it's all based on the backend types. And you can see that I'm using like tags.get and the get autocomplete. It's working. You can pass the parameters, same parameters to use query that you would usually pass. And here is my router. And this router, you can see that it's public procedures because I didn't want to work with that. But let me first show you the application because I forgot about that. So application is something like this. It doesn't have anything. I can say name and value and go save. And there's some form that gets submitted in the end. And that's this create method. So you can see that it has a name, and I'm connecting to Prisma. Of course, I don't have any architecture here because it would be harder to understand. But you can see also that this mutation doesn't return any type. And the whole idea that it doesn't return any type is because it's going to be inferred based on the Prisma. But I said, like we used Firebase, so we didn't have a Prisma. So we had other layer like repository where we would actually ask for this type, and we would use it on the front end later. And you can see that we have those objects. And our form is actually connected to router inputs. And it has, okay, router inputs, tags create. And then I can use this on my form. And it will infer types. For example, React hook form accepts the default values, it will infer everything. And you can see on mutation that it is actually saying that this is parameters that are going to get returned. And it's again something that gets auto-completed. So let's try to break a little bit and see how it works. So this is my Prisma schema, and I'm going to change that name is no longer called a name, it's going to be called title. I'm not sure if you can see it, but I'm not going to run anything special there. I'm going just to generate the types from Prisma and then do the DB push. So I want to update my SQLite here. And it's going to drop actually everything because I don't care about my data. But things are changing now here at the top. And you can see that things are actually red. So everything immediately changed because my backend no longer returned these types that has the name. And I can just go to my front end and I can say, okay, this is going to be called title because I want to rename it. And this is also going to be the title. And you can see here that I can actually get the type safety. And then what happens with backend? So if I go to backend and I say that I have the name, but I actually want to change this one now to title because it's a title. But again, my backend shouldn't accept the name. So it should actually accept the title here. And I'm going to change this too. But now my form is breaking immediately. And this is, I think, good feedback loop because you no longer have to go and search on front end, okay, where is the error? What is happening with this? And you can see here that my register is actually failing. And it's because it doesn't have the name anymore. And same here is here. So if we update this one, it should actually work. I hope. Nothing works on the first run. Yep, it works. And it's small demo because with tRPC, I think it's all you would actually want to know that if you change something on the backend, you have a fast feedback loop to the front end. You don't have to guess anything. So let's cover a little bit more things. So somebody can say, why not GraphQL? So GraphQL is a good solution to this, but it's going from code generation that you create in GraphQL, and then you have output the types. And if you're doing the code generation, you depend on certain libraries to do that, and you cannot actually modify anything. While if you're using the tRPC, you get everything there. You don't have to do anything like anything fancy to achieve that. And we were a smaller team. Will that work in bigger team? I'm not sure, to be honest. But like, there was like 10, 15 of us. We were contributing to the same thing. It was a startup. Things worked like a charm. And GraphQL, as I said, it's coming with some costs because you still have to have GraphQL server in front of everything and deploy that. And we didn't want to do any complexity that would actually extend our delivery time. We just wanted to deliver. There is also a good solution, like I didn't mention it earlier, there is a Blitz.js, and it also allows you to have the type safety. I know that at some point it was tied to Next, but I think they decoupled from the Next a lot. I haven't used it, but it would be also interesting thing to explore. And the end result was actually better productivity and less errors. And we were actually happier. At least I was happier, but I know that everyone else in the team loved it. And I want to say that like loose coupling is not something you actually want here. If you have the loose coupling, it's everything is based just on the agreement. So loose coupling means that me and the backend is going to agree what's the types and what's backend going to return. You can also export this from OpenAPI schema or anything, but again, I don't want to do code generation. I just want to have my API written in something that will actually give everything to me for free. And the main takeaways is that you can do it even without tRPC, but it requires effort. And the question is like, do you want to spend that much effort to do it? GraphQL also makes sense, but it's a lot later on the roadmap. For example, you do that when you have multiple teams and they have different API contracts. While you don't have different like teams and different backends, and they are written, one is written in Scala, one is written in Java, one is written in Node. You actually don't need the GraphQL until then, until you basically diverge and create multiple teams. Like I used GraphQL, but it was because we had like 10 teams, and Frontend actually didn't want to send 5 requests just to do something. They wanted to use the application API, which was the GraphQL. But as I said, for smaller teams, I think tRPC is enough. And the point is also that if you use the tRPC, you can still have the REST API on the side. So you can connect to your third-party clients who want to connect to you, and you can define these REST APIs while you have tRPC for your frontend. And the main takeaway is also that you don't need anything fancy to have end-to-end type safety. You can do that pretty fast, and you can do that in like a couple of days if you have Node on the backend. If you have something else, yeah, it takes time. So we can move to questions. That would be all. Thank you.